Bună ziua și bine ați venit! O să vorbesc în română, deși ar trebui să vorbesc în engleză ca să ne înțeleagă și colegul Bolut din Slovenia. Așa că cred că cel mai corect ar fi să vorbesc în limba engleză. Ok. Welcome to our event. As it's saying in the title, today we are celebrating 5 years for OpenStack Foundation and 1 year for OpenStack Bucharest group. We'll have today 3 presentations. First will be a presentation about OpenStack 5th birthday. It's an update from OpenStack Foundation. And then we'll have a presentation from Adelina Tumenian from Cloud Solution. And she will present you Open Compute, OpenStack, Open vSwitch, and Open Lately. And then we have a presentation from Borut Risman at Stack Labs. What happens with server in 1990 is now happening in networking. I think it's very interesting from this point of view. And beside that, we will have a small celebration. Since it's a birthday, we will have some beer and cake and pizza. But this will be about 8 o'clock. Okay? I will start with the presentation with an update from OpenStack Foundation. So, OpenStack mission is to produce ubiquitous open source cloud computing platform that will meet the needs of public and private clouds, regardless of size, by being simple to implement and massively scalable. Sorry, I have some technical issues. So what happens with OpenStack trends and things in year 5? We have OpenStack Powered Planet, delivering on cloud interoperability and federation across families and geographies. Application in OpenStack, new community application catalog and first application guide, providing more support for developers targeting OpenStack clouds. Platform from next 10 years, OpenStack gives users the ability to integrate and test new technologies like containers and other emerged technologies. So the community grows in 5 years. You can see there are 27,398 members which are contributing to the code. Cumulative contributors, OpenStack user group, more than 80, 30 million lines of codes, more than 165 countries and 509 organizations. There are some information about Vancouver Summit announcements and demonstration. You will have the presentation on the Meetup platform, so you can download there, so you can also have the link. OpenStack Powered Planet. Interoperability testing now available for OpenStack Power products. So all new products applying for OpenStack Power Logo program and naming rights must interoperability test. So you can now find validated products and interoperability test results in the OpenStack marketplace. OpenStack Identity Federation Proof of Concept. There are 32 companies are committed to deliver federated identity by end of 2015 in Vancouver. Digital Film Tree demonstrated how its team spins up resources on their own OpenStack private and can instantly scale its instances out to the public clouds with HP and out to hosted private clouds with Bluebox. New community application catalog. Community members can now share the application including the forms of plans, images, heat template, and Murano packages designed to integrate with OpenStack clouds. Developers can now experiment with emerging tools like containers by developing packages to leverage the proven building blocks of OpenStack. Get involved at application at OpenStack at work. OpenStack Magnum plus Kubernetes demo. Magnum is a new project aiming to make containers of first-class resources in OpenStack Kubernetes. It's a container orchestration engine that can be deployed by the new community application catalog and also run on top of OpenStack clouds. You can watch also the Vancouver Summit site. User story presentation. Probably most of you knows about the biggest OpenStack implementation. Walmart, it's powered by more than 140,000 OpenStack cores. So, on last Thanksgiving Day, they did 1.5 billion pages viewers, November and December. The 2 months where they have to satisfy all the needs of the customer, and that they did with about 140,000 cores. Also, 100% of PayPal transactions are powered by OpenStack. A rumor appears in 2014 saying that PayPal will replace all the service of VMware with OpenStack, and they already did it. So they are using Havana, more than 12K hypervisors, more than 300K cores, 10 plus availability zone, 15 plus virtual private clouds, 1.6 petabytes block storage, 100 KVM, 100% OVS, spring 2015. During the holidays of 2014, they were running 66% of PayPal front and mid-tier on OpenStack. The number is now 100%. If you have doubts about OpenStack running in production, this is the proof point for you to say that OpenStack is doing financial transaction. Probably this would be a very good example for the banks to present. User groups picking up. How has OpenStack impacted your career? And here are some statements. OpenStack has impacted my career tremendously. Every day I'm learning something new, like all of us. After working at Equinix, I founded my own company and developed our application on OpenStack. Somebody from Turkey. Also in Brazil. This is the interesting one. OpenStack has helped me to find 2 new jobs and raise my exposure in the open source community in general. This guy, Doug Hellman from Atlanta User Group. OpenStack User Group goals. Have more attendees each meeting by providing completing speaker in a fun environment, program PDX user group. Raise awareness about OpenStack, especially for students, engineering school and university. Morocco user group. Better awareness and find people who would really be interested in being part and contributing to the community, not just the winners. Filipino user group. We want to demonstrate how OpenStack can be useful for the end user, Argentina user group. Organize tutorials for beginners, Stockholm, Nordic group. Where do you see OpenStack in 5 more years from now? So we have some thoughts here. By the way, this will be one of our tasks. If you want, you can share your thoughts about OpenStack after we end the presentation. Up its standard of cloud computing and become the engine of thriving cloud economy, Shenzhen, China user group. As basic and common element in data center, Sevilla, Spain user group. More stable with more diverse set of features and robust community, Atlanta user group. At the center of private cloud software offering, Turkey user group. As popular as Linux, Vietnam user group. Important dates. July 19, 2015, OpenStack 5th anniversary. It's the exact date. October 15, 2015, Liberty release, the new release of OpenStack. October 27 to 30, OpenStack Summit in Tokyo. April, M release. And April 25 to 29, 2016, OpenStack Summit in Austin. So, Tokyo, it's the next OpenStack major summit, quite far from Romania, but never know. If you have any question. Okay. I will invite Adelina to... Yeah, come on.
Okay, I saw the presentation and well, I'm not very familiar with OpenStack. I have quite I see it's 5 years now since you began. But I want to ask you what are the goals for the Romania community?
Yes, you're right. The goals for the Romanian community is to become at least one of the contributors to this community, because in this moment I think there are only few companies who are doing that, and these companies are more or less part of bigger companies, and they are doing some regional project. So,
okay, I'm coming from a corporate, not very, because I understand what open source is. Every corporate treats open source in one way or another way, its own way. And I want to clarify myself, what firms or what organization are you talking about? Because I understand it's open, it's open source.
yeah.
Okay, could you please elaborate more about what kind of open source do you look for myself? Because I'm not open is open, you know.
The idea is that OpenStack Foundation is trying to help the community itself, and it's trying to keep, it's trying to keep some regulation regarding this OpenStack production, because as experience until now, there are a lot of open source projects which were not going very well due to the non-standardized approach. And they want to avoid this problem by keeping this standardized principle very clear and very easy to understand by everyone. That's why there are a lot of releases every 6 months, and these releases are very well covered in terms of technical and specification part. What is Foundation doing? They are trying to keep the movement in a clear direction, not going to any part like going close to Microsoft or going close to IBM or close to VMware. Or they are trying to keep their own road and help all the people to be on this road. And I think this is the major factor that keeps the community so close. I think OpenStack is, from my point of view, the success story for an open source release.
Yeah.
Comparing with other projects of open source.
Yeah, I should have asked maybe one more question.
Yeah, no problem.
What are the main contributors to this to the foundation?
For this foundation, there are a lot of each major contributor, each major company who is a contributor to OpenStack has the right to propose one or two members in the board. And this member has to be elected by the community. Yeah? So all the members which are part of the board of OpenStack Foundation has been elected by all the others, including me. I was voting for that. All the members of OpenStack can vote for that. So in this moment, these guys, which are a member of OpenStack Foundation, they are not really acting in their own company. They are acting only on the foundation side. I met in Budapest 2 weeks ago, a guy, 3 weeks ago, a guy who was acting for Rackspace initially, and now he's acting for the OpenStack Foundation only. He's not mentioned anything about Rackspace, he's not mentioned anything about any other company, he's mentioned only about OpenStack Foundation. And they're trying to keep this spirit very clear and very transparent to all the members. I know that OpenStack has open source as an alternative for other software releases haven't had a very good name. But they are trying to turn it back around to make it a very predictable and very easy to understand for all the others. Because it's the only chance for an open source software to penetrate the market. The proof is that PayPal, one more, and probably you don't know BMW, the whole data center of BMW, in fact they have 4 data centers, are on OpenStack technology from 2012 already. So imagine that all the IT environment is conducted by OpenStack.
So you are on competition with the corporate private cloud. I see. Okay.
So for the Romanian community, I think it's important first to generate a very strong community, technical one, And this is the purpose of this meeting. I'm trying to get together people who are interested in this technology. We cannot succeed without people. I started to make this community last year. In this moment we have on LinkedIn about 477 people, but not all of them from Romania. Some of them are from outside, but they are bringing information. My purpose was to bring the people who can lead us and who can help us in keeping a very good level on technical area. On Meetup we also have 97 people in, so I think the community is growing quite fast. There are a lot of OpenStack projects in Romania, as I mentioned, but these projects are part of multinational companies who are doing that as a global projects. So they are not a typical Romanian project. So they are a Romanian project, part of international project. That's why it's a bit frustrating that we cannot show any, let's say, typical or authentic Romanian project on OpenStack. There is, as far as I know, a project in Polytechnic University, and it's based on OpenStack. But it's, of course, it's a proof of concept made for the students, and I think it was released last year, 2014. But I think the room for the project is quite big. So we are still in the beginning, and we can do much more better. Any help in this direction from any person, any involvement, it's a positive thing. Okay, I will invite Adelina to give us a technical.
Okay, so I changed the title of my presentation. I'm calling it the monthly cloud now. Okay, so I am Elena Tuvenia. I work for a company based in Timișoara, but we have offices in Iași as well. The company name is Cloud-Based Solutions. I am a cloud engineer. I mean, all of them are invented labels. But I am a contributor to OpenStack. I am working on OpenStack for almost a year now. I've contributed code to the Nova project lately, but Neutron is in there as well. Cloud-Based Solutions is a company that's dedicated, so right there, bringing OpenStack and Windows together. But more than that, we try to bring Windows to closer to the OpenStack. We're not intending to make Windows open source, of course, but we identified that businesses in general like Windows because it's enterprise, because that's just how it works. So we're trying to fill a gap in that market. Okay, so that's enough about it. Working with Windows and OpenStack, we at some point for this scenario, let's say you're an enterprise or small, large business, doesn't matter, and you want to build your own cloud. Okay, you would start by, I don't know, thinking about some goals you want, some criteria you want, some criteria, I think is the best word. And you're going to say, okay, so I want my technology to be open source because it's community supported. And like we heard previously, OpenStack is community supported. It's huge. It's supported by big companies, big names in the industry. And that's something that you usually want to get from the community support. Okay, then you want your cloud to be horizontally scaled, which is normally desirable for anything. Then you want support for multiple hypervisors because you would have workloads that are better in KVM, or better in Hyper-V, or better in Sensor, or even in VMware. It doesn't really matter. And then you have want multiple SDN options, but most importantly, you want a seamless deployment. Or, let's just say a painless deployment as much as possible. So, of course, the obvious conclusion is OpenStack. So, my presentation is done this year. Because OpenStack fits like a glove. It's open, it's horizontally scalable, it supports multiple hypervisors, it's totally hypervisor agnostic. It doesn't care what you're using. And you have multiple SDN options. On the flip side, it is not fully, automated. OpenStack is horribly complicated, to put it lightly. Just to deploy it, it's very, very complicated. There are, of course, great solutions on the market. You have RTO, you have SaltStack. You can deploy it, but it's just difficult. And to use RTO or SaltStack, it's complex. Yeah. To use RTO or SaltStack, which are great, you already need a provision hardware. So you cannot go just from the beginning. So we thought that, given our experience with open source, we work on some other different projects that I'll talk about with the Canonical to bring Windows support. And we thought, hey, why not just, I don't know, somehow merge all these things we're working on, combine them with OpenStack somehow and build a cloud. Or make it easier to. So, okay, so our story basically begins from hardware, right? You want to build a cloud, it's pretty, but you need hardware. And there's this thing called the Open Compute Initiative. It's the Open Compute Initiative was started by Facebook in 2011, I think. It was started with the goal of sharing, mostly for standardizing data centers, for standardizing compute units, and they basically designed standards, open, freely available, standards for dimensions, specifications for compute units, power consumption, interfacing, and all these things. The Open Compute Initiative, basically, their idea was this. Let me design my hardware and make it freely available to everyone, and then just go to whatever vendor to build it. It doesn't matter if Dell builds it or some Chinese company. Of course, if I want to take the risk, but the point is, the schematic is freely available to everyone. Okay. Microsoft made their OCS, Open Compute, Open Cloud Service, or something like that, which is basically an implementation of this Open Communication. So they basically designed that rack over there. They designed every component, made it really available. And one of those racks looks like has like 32 compute nodes. It's huge. It's only one blade of that. I mean, one compute node has 256 maximum of 256 gigabytes of RAM, a total of 282 terabytes of storage. So it's huge, right? Okay, fine, not Facebook data center huge, but it is pretty impressive hardware. And somewhere in the summer we got to play with something like this, and that's when the idea for automating this deployment started. Okay, so we have the hardware. But before I go on, I want to talk a little bit about cattle versus pets, because this is what we're aiming at. Let's say you buy or make or whatever a rack like that. You basically have a rack full of before anything else. You know the cattle versus pets analogy. It's basically, cattle are units. They're disposable, they die, it's sad, but not that much. You buy a new one. Pets, you love them. You don't want them. If something happens to one, you're going to be sad. It's emotional, it's personal. So, basically when you get a rack like that, it's full of cattle. One way or another, it's exactly the same thing. And that's the practice right now. I mean, if in your data center, if a server breaks, I'm so sad, but I will replace it with another. I'm not going to stay and figure out why and stuff like that. There's no time for that. Okay, but in this scenario, some entities are our pets. They are basically, well, we care about them and we need to figure out some solutions to take care of them. And those solutions, as we'll see, are in software, never in hardware. Okay, so we talked briefly about this because it's important to know where the idea came from. Now you think, okay, fine, I have the hardware, what do I do with it? And in comes another project we've been working on. It's called MAS, Metal as a Service, because everything is as a service now. MAS is a project developed by Canonical, and it's basically a way to provision all your infrastructure. The thing is, because obviously if you have the hardware, you're not going to go to the USB stick and install your operating system on each and every one of them, because it doesn't make any sense. And of course, I'm not telling you anything new. I mean, this is happening. We solved this problem a long time ago. But MAS has one advantage, and is the fact that it's seamless and very, very easy to use. Basically, MAS looks like this. There's a controller over there. There's a controller. I drew it as a box. Imagine it as a compute node or something, but in reality, it's much more complex. In there's a MAS controller and some slaves, but for the purpose of this, it doesn't matter. So you have a MAS controller. It needs to have two interfaces. One public to talk to the outside world, and for you to talk to the MAS controller, and one private, which is shared between all the nodes in your cluster, in your rack, let's say, but you can share between multiple racks, so it's not limited to a unit like that. Okay, so what does MAS do? Basically, it provisions your hardware, as I said. It's very simple, really. All the nodes are connected to their private interface. And when the nodes start, the first time they power on, MAS detects them by their MAC address. And at that point, MAS pixie boots a very, very small Linux image puts a very, very small Linux image. And then, when that boots up, basically the node can get an IP because, well, it has an operating system, and it will get an IP from Mass's DHCP server. Okay. Then after that happens, the node will restart. Mass boots a full Linux image, Ubuntu of course, because canonical. It will boot a full Linux image and do some polling, take some data from the node, like how many cores, how much memory, how much disk space, and some other stuff. Okay, and after that's done, the node is ready to use. It's active and ready to commission and install your operating system of choice on it, if you choose to do so manually. And when I say manually, I mean I want that there done. So it's really, really seamless for the user. I mean, as I said, 32 compute nodes on that little box, right? I don't have to touch it again for this to happen. Okay. Okay. This is what we did in MAS. We built Windows imaging tools and some other stuff. The link is there. Okay. Next, we thought, okay, as I said earlier, I have the hardware, I have the provision. What do I do next? I need to install OpenStack, of course. And we come to the discussion I had earlier that you can use iunie, you can use OpenStack, you can use a variety of other stuff. That's fine. But we chose Juju. One, because we have experience with it and we worked on it. Two, because it was born in the same place as MAS. It was built by Canonical, but they're basically two sides of the same coin. Right? On the one side, you provision, on the other side, with Juju, you orchestrate. Juju is a very good project. It basically manages your provision hardware, deploying it by using some things called charms. Another cool feature of Juju is that it bootstraps, and that's just their term for talking to. So Juju can talk to MAS in this situation. But the good thing is it can talk to a variety of other providers. You can talk to OpenStack, you can talk to Azure, you can talk to EC2, you can talk to mostly everyone. Get to that. So what I'm trying to say is that by bootstrapping, it selects MAS as a provider, and when Juju says, okay, fine, I want to install this thing here, this charm, I want to deploy it here. I'll talk about charms in a second. So when it says I want to deploy this charm here, it basically starts, okay, I'm bootstrapped to MAS. MAS, give me a node, a compute node. And it will give Juju a compute node. It commissions it for the user Juju, and all is fine. So, basically, as I said, that MAS is the provider of machines to Juju. Talking about charms, what are charms? And honestly, I cannot put it any better than that. It's a thing that installs something. In reality, it's a bundle of executables and artifacts and whatever. But the main important thing is that a charm can be written in any programming language. It needs an entry point and some other specific things related to Juju, but it needs to be able to be executed in a command line. So that's why charms are usually written in Python, Bash, PowerShell, script. Okay. So this charm is basically, if you're familiar with SoulStack, it's a recipe or something. You just simply say, I want to install this, in this way, with these parameters. Charms can talk to each other, they have relationships, and so on. But the thing is, for deployment for a user, it's very simple. I mean, let's look at this picture. It has a really cool UI. I'm not a fan of UIs, drag and drop these things, these lines here, the connections between them are relationships. And at this point in our scenario, we're deploying OpenStack. As you can see, we have there's a cloud controller, there's a Keystone, Charm, there's Glance, Single API, Nova Compute, Nova Hyper-V. These are Hyper-V driver, so another Nova Compute, our Windows Cinder, our driver for Cinder, and so on. The thing is, you just drop and drop this. Be careful with the relationships. Boom, you have cloud. And this is, again, this is our scenario. This can be, of course, configured to your specific needs. It's not set in stone or anything. But as you can see, it's really, really cool. It's really fast. No problem. Okay. Juju Windows support. So yeah, Juju up until version 1.21 did not work with Windows. I mean, you cannot deploy channels on Linux. So if your choice of operating system was Windows, I'm sorry, you cannot. It was strictly related to Ubuntu, and it was strictly related to Ubuntu to the point that it had hard-coded in its code stuff like default user Ubuntu. Okay, we added Windows support and we built up chunks. And important for this scenario is the OpenStack components for Hyper-V. This is Nova, Cinder, Neutron, what we have, and a bunch of other chunks like Active Directory, Exchange Server, SharePoint, whatever. And the last one over there, failover clustering. So at this point we can use Nova with failover clustering. So with Hyper-V, Windows 7 Hyper-V supported failover clustering, we can use that in Nova. We can leverage that in Nova, which is very cool. Nova at this point doesn't really have a failover. Well, it does have something, but it's not as seamless as, and it's, from our point of view, the one that Windows does is the most appropriate because it's embedded, it's integrated, and it's fully supported. Okay, going back here, as you can see, we also have the Active Directory chart here. This is a neat little trick. We made the Active Directory talk with Keystone for authentication, so that's also cool. Okay, so to recap, we have, at this point, we have the OpenStack, right? We have our cloud. We still need networking because that rack basically has vanilla switches, right? They are just all the nodes stuck to each other, that's it. It doesn't have routing capabilities or so, and it doesn't need to, because the trend is most of the networking will be done by software. It's flexible. Actually, if you even look at the rack, it doesn't even have cables. So it just, has connectors. No cables, no nothing, so you cannot move anything there. But we chose to use OpenSwitch because, well, of course, because it provides capabilities we wanted, like baseline. Because it can talk very well with KVM and Hyper-V. We actually ported together with VMware, we ported OpenSwitch to Windows. So at this point, OpenSwitch works on Windows. It has the same command line interface as Linux. It supports NSX, that's VMware's thing. And it supports Open Daylight. And it's fully interoperable with other hypervisors. And then, of course, this slide about Open Daylight, which I'm going to jump over. It's basically we choose Open Daylight to manage network flows, rules, and so on. Because, as you said, it integrates very well with OBS and OpenStack. And of course, Hyper-V scenarios are now also possible because we ported OBS and Hyper-V. Okay. So, at this point, we have our clock. we have orchestration again. Because at this point, as I said, you can either choose Eat, which is an OpenStack project, and it's fine, whatever. But you can also use Juju again, because as I said, it bootstraps on everything, including OpenStack. Okay. So these were basically the steps we took. And then, to sum it all up, we packaged all of these things into a tool we call Imagine. It does everything we talked about. Well, it's Imagine and some other Python scripts, but it does everything we talked about, and the end result is that a full OpenStack deployment with 5 KVM nodes and 25 Hyper-V nodes, and Cinder and OBS. So from power on of the rack to full usable deployment, it took under 4 hours. Under 4 hours of unattended, just looking at the thing. I mean, we never had physical contact with the rack. It's not here, it's somewhere in the States. So we never touched it, we never looked at it. And all the deployment happened in under 4 hours. So it's very, it is seamless, it's fast. And it's, I don't know, it suits our needs very, very well, as you can see. I mean, 4 hours, just to tell you, there are days when because since I use OpenStack Master, I'm using their stack for my deployments, and there are days when their stack and me cannot understand each other in 4 hours. So that happens. But that's basically screw ups from another part. So all of these things we're talking about, you can try them out. Either in a virtualized environment, either if you have, I don't know, data center rack, whatever. So these are the main links for Imagine, our installers. We also on the site have Windows Server 2012 R2 image, pre-prepared with cloud need. So it's just downloaded, put in a glance, and that's it. That's basically all I have to say. Questions?
How do you service Imagine?
Well, the thing is, everything we use here is open source. So, other than, well, we did need packages and we cannot particularly sell something that's open source, right? But it is intended mostly for small deployments, right? So a small business, or medium business, whatever, that wants its own cloud, that's where Imagine fits better. On a large deployment, the same thing still applies, but not with Imagine. Because, of course, being a large deployment, you need some control over it, some higher level of control. Let's just put it this way. But it's quite popular. I mean, we have our ask.cloud is that whatever. You know, and we start having questions about it. When I was looking at it, what are they using? Let me check what to say. Other question? About, and not necessarily about this, but I'm pretty sure that Windows and OpenStack are not two things that, you know, can come across very, very well in conversation. So we do try to steer these things towards open source, but I'm sure people still have questions and have
to. You get support from Microsoft?
Well, sure. If you buy your Windows Server 2012 R2, you will get support.
No, I mean for the development support.
Us as a company?
Yeah.
That I cannot tell you. It's not. No, I can tell you.
Because from my point of view, the most important thing in this direction is to have support from both sides.
Yes, of course. This is what pertains to this discussion we had earlier. To your question, OpenStack is supported. OpenStack cannot exist if it's not supported by corporate giants. It cannot. It simply cannot. There was, at the time that all these projects emerged, there was OpenStack, there was CloudStack, I think there was Eucalyptus. I'm not sure, but there were all those things that OpenStack tried. Because basically CloudStack was too monolithic. It didn't really try to build a community, and it was, OpenStack is, the OpenStack Foundation understands very well that you cannot do this without corporate sponsorship, of course, because me and a laptop, sure, I do my development on a laptop, right? For virtual machines on a laptop are just enough for what I'm doing, but testing it will never happen. And OpenStack understands this, and they have, I mean, every piece of code that's submitted is tested by CIs, right? And a CI requires serious hardware that you're not going to get it anyway. And so yeah, we have, I think this I can say, we have a Hyper-V CI, which, you know, comes from Microsoft. We run it with them, but other than that, I can't say. Okay, this was basically it. I just wanted to his question, because sitting on the chair I thought about it. Because I was mostly thinking why OpenStack tried, and mostly it's because nobody, I mean, it is open source, but not really anyone can do anything, right? So if I want to add a feature, I have a month every release to submit a blueprint, submit a spec. A spec is specification, is a detailed document stating what I'm going to do, why I'm going to do it. It has to be approved. Then my code has to be approved. My code, any code anyone submits, runs through gazillion of tests. So it's not that easy to.
But I think this project powered OpenStack, where you can test also the. I think it's a good project from my point of view for all the contributors who also have their own application based on that.
Yeah, sure.
So it will be a kind of security check, or let's say additional supervising for the products.
But as for where OpenStack is going further,
I will invite Boru to make the presentation, and he will tell us about the networking.
Hello. Okay, so I'm Boru. I'm working for a company, Stack Labs and QSTC, which is based in Slovenia. We have been in the OpenStack world for almost 4 years now. So I would that's right. So, we met with Daniel 3 weeks ago at an OpenStack regional event in Budapest, and so he suggested that I would come here, and so I did. Thank you. Was anyone in Budapest 3 weeks ago at the event? Oh, you were. Okay, so but everyone is already using OpenStack or not? Yeah, well, you are. So who is not? I mean, it's okay not to use it. That's why we're here.
Project.
Okay, so I will talk now about the revolution in networking. So I will ask another question. Who is working with the networking equipment like switches and so on? Okay. Okay. Okay, I'll have to do it with hands. Okay, so Cumulus. Cumulus is a company that is bringing this revolution to networking, and although maybe you have not heard about it, it's not from yesterday. It did not start yesterday. Actually, it's now 5 years old, and the first networking switches using Cumulus were people started using them about 3 years ago. So it's not very. It's not from like yesterday. And this is an overview of the people that started this company. As you can see, they have worked with many of the well-known IT companies before, like Cisco, VMware, Google, and others. So when Cumulus Networks was started, in networking, also the networking engineers wanted to learn from what we call web scale operations. Web scale operations are operations where a data center is very big, like the one on the picture. And if you have, very many switches, then it's important that they don't cost much, that you can automate the installation and configuration changes, and that you can use the same hardware, or that the hardware does not influence how the system is working. And Cumulus and all the big companies like Amazon, Facebook, and Google have been using this type of networking for several years, and Cumulus decided to bring this networking also to other users. So what is Cumulus? It is about changing the way networking equipment is built. Everyone, what has changed in networking in the last 15 years? Not so much. There were a few protocols, but otherwise everyone is using typically a Cisco box. And everything is coming from Cisco. When you buy a Cisco switch, you also get the operating system that makes this hardware act as a switch. Open networking is that makes the switch a switch. That has happened in servers a long time ago. Many of you are younger and you don't remember that if you wanted to buy a server in 1990, you could only buy a server together with the operating system. So someone would buy a Sun server with a Solaris operating system. Everything came from one company, or the same from IBM, or if you wanted to buy an iunie server, you have to buy the server with the operating system. And about 25 years ago, then hardware servers became standard, and you could use different operating systems on server. So it was not important whether the server was from HP, from IBM, or from Dell. You could use Microsoft Windows and then later on Linux on this hardware, and it didn't matter what hardware it was. The applications performed the same. And what has happened is in the world of servers in the 90s is now happening in the network. With Cumulus, it is not, you don't have to buy a Cisco switch to have a good switch. You can buy standard hardware, switch hardware, and put Cumulus Linux on top, and you can change the hardware as you want. And this is actually the revolution that is happening, and it has a lot of benefits for the people using networks. Like it had a lot of benefits when it was possible to use different operating systems on different servers, because the servers were effectively all the same. So Cumulus is the company that 3 years ago developed something which is called ONIE. It's a small piece of software which was mentioned earlier, and it's comparable to Pixie boot for servers. It provides a way that a bare metal switch boots with the operating system that you provided. And that's the ONIE was made a part of the Open Compute project, which was the initiative led by Facebook when Facebook started to build very big data centers and decided that they wanted to be flexible and that they don't want to spend too much money on hardware. In the center, Cumulus is the company which is in the center of this revolution, and the advantages of using Cumulus Linux for your switch is the same as using Linux on your servers. You can use the same tools that you use with Linux. You have a lot of tools that you can choose from, and you already have knowledge about the technology, and it is much more affordable than buying a switch from a big company. By separating the switch hardware from the switch operating system, and both elements are standard, the users can and the system administrators have the choice and flexibility of using a lot of applications or administrative tools. So you can use different network virtualization. You can choose between PlantGrid, VMware ISX, Nuage networks. You can use different orchestration engines. For network automation, you can use all the popular tools, and many of them are also free of charge. What Cumulus is also doing is testing different hardware for compatibility. Currently, there are 11 hardware manufacturers which manufacture so-called bare bone switches, and these 11 companies, Cumulus has tested so far 11 vendors. So you can buy a switch from, for example, HP, which doesn't have an operating system, and use Cumulus on it, or you can use a Dell switch, or you can use an edge-core switch. If you want, your network will run regardless, the same way, regardless which one you choose, because this hardware has been tested for compatibility. You put the Linux, Cumulus Linux operating system on it, and it's easy to replace. Because you as a user, you are not locked to a particular solution. You are flexible, and because of the flexibility, you can save a lot of money. If you go into the open networking, you can practically buy a 10 gigabit switch for the price of 1 gigabit switch, which comes from a company like Cisco. And if those of you who are familiar with networking, you know that into each switch, if it's an optical switch, you have to put in these, let's say, connectors, which are called SFPs. And then, if you have a Cisco switch, each of these connectors, or called transceivers, are also very expensive. If you take an HP bare metal switch or an edge-core bare metal switch, these transceivers are much less expensive, and you can save money again. So there are lots of ways in which you can save money by using open networking. It's because of automation that you can use. It's about the flexibility, because you can choose different hardware, and because it's simple to add capacity, and it's simple to configure because you are already familiar with the tools. Cumulus Linux is not free, because Cumulus guarantees to you that the switch will work regardless which hardware you use. So that's very important, because Cisco also guarantees you and supports you that the switch that you buy from Cisco will work. And the same situation is also with Linux, with Cumulus Linux. If you can have a network with an HP switch, a Dell switch, or an edge-core switch, and the Cumulus company will guarantee that Cumulus Linux runs on all of them, and it will help you troubleshoot if something doesn't work. And that also happens. Whoever is using Cisco knows that he has to follow the Cisco support, well, not every hour, but regularly. And the licensing is very simple. It only depends on the switch speed. Regardless how big or small the switch is, it always costs the same. Cumulus has been tested with various scenarios. For example, for VMware, for OpenStack, or for big data like Hadoop. It is used by large telecom companies or university networks today already in many countries. So in short, what is Cumulus? It's a Linux operating system which was designed for, which runs on bare metal network switches. It provides you with an easy and cost-effective way of managing your network, and you are not locked to one supplier. Because of the management flexibility and tools like Puppet or Chef, the provisioning and reconfiguring the network will be much faster than with traditional networking equipment. And because of that, Cumulus solves a lot of problems. So you can go away from high-cost network switches. You can automate workloads. You are not locked to one company. You can provision applications very fast, and there are more and more choices every day. 2 years ago, there were just two companies which were compatible with Cumulus, and now there is 11. Whoever is in networking can also try out how the Cumulus works. There is a lab available for that, and whoever would like to do that can tell me that later. That's the end of the presentation. Once again, what has happened in servers 20 years ago is now happening in networking, and because of this change, it will be much easier to buy 10 gigabit switches than it was just half a year ago. Because now with Cumulus Linux, 10 gigabit switches just became much cheaper and they're much easier to manage. Okay, so
what are your servers that you use as a location, country? Which country?
which servers?
Your servers from the company that you work, let's say.
Yep. The servers that we
Slovenia,
use
yeah.
for our company. Okay, well, our company doesn't have a lot of servers.
Alright.
So we have, let's say, 20 servers, and we have a small, we have them in a small data center.
Locally.
Yes.
So not in US or other country.
No, but we also, it's not a typical production environment. We do a lot of changes, every day, because we're more of like a development and training company. So there's lots of changes to the infrastructure. So it's practical that we can do more around or whatever.
Basically, I want to clarify myself. Basically, you install this Cumulus Linux like a firmware. Or what's
The
the way to
firmware,
do it?
it's not firmware on the switch. The switch has this piece of firmware which is comparable to PXE boot, and then let's say a configuration server that you would have would push the current version or the version of Cumulus that you're using to the switch. So it's deployed at boot time. Well, once again, the big revolution is really about the flexibility that you have. I mean, you're all used to the flexibility of Linux, but this flexibility where you can choose whatever hardware you want, but this flexibility doesn't exist in networking. You have Cisco switches, they're expensive, and if you want to add another switch, then you have to buy again a Cisco switch, because the network management is from Cisco, and it's probably it won't work if you put in a Juniper switch. And because of that, it's much more expensive. So that's really what's happening now. It's really good news.
You can stack on the switch. You have
Yes, you
possibility
can
to- yeah,
do
you
that
You
as
can
you can.
aggregate
Yes.
many switches as one. Yeah.
Yeah, you can do all the things that you're used with, with the switches,
What's the downside? What would you say is the downside?
Well, what's the downside? I would say first of all, you need to have an environment where automation really brings you benefits. So if you have just one switch, you don't really benefit. So that's a downside. Doesn't help for a company with 5 PCs. The downside is also that, let's say, if you, I mentioned Sun Solaris. Sun Solaris was an environment which was very much tested. Probably 10 years ago, Linux had to do more troubleshooting of Linux than of Sun Solaris. And maybe this is also the situation here. But you shouldn't be worried about that. I mean, it's better to save a lot of money and do some work than spend a lot of money on the hardware.
It works only on bare metal or as a virtual appliance?
Well, it works on bare metal.
Only
Yes.
on bare metal.
Yes. Yeah. I mean, here you don't want a virtualization, or not the full virtualization, because of performance. I mean, these are high-speed switches. They're as fast as Cisco. So you can run on 40G switches.
It's core. It's core switches.
Yes, you can run it on core switches.
Because I know about Cumulus 4 years ago, when they signed an agreement with Dell about this.
Yeah. And now it's running also on HP, Quanta, Edge Core,
And
Penguin.
as I saw Dell switches, four-step switches. They are four-step. There are the switches that Dell bought on four-step.
410. Okay. Yeah.
They also have the operating system.
They used to have, yes. I mean, you can buy Dell switches with their old operating system or without the operating system.
You can duplicate the traffic. You can have the duplication of traffic for analysis and use.
I don't know how to answer that, but I think if it's possible on Cisco, it's possible here too. I mean, essentially it's Linux, it's traditional Linux. It's just interfacing with the switch architecture in such a way that it can process the packets at wireless speed. It's also interesting because you can, on this switch, you can, if you're interested in developing applications that work with the network traffic, like all kinds kinds of network analysis, it's very easy to do that because you can put the application, you can develop the application on Linux, and it will use this, it will run on this switch. In the old days, if you wanted to have a monitoring system for a network, you needed a special box for monitoring. You had a switch and then a special monitoring system. So this is also simpler.
Can you use it also on wireless devices?
No, there are no wireless devices. But you know, on wireless devices, you can. Wireless devices are typically there are no high-speed requirements there because typically the small wireless router, so you can run. You're running Linux there anyway.
So these are the top of the rack and data center.
Yeah, this is data center core switching at 40 gigabits. Okay, so think about it and tell others who want to save a lot of €1,000 when they're buying a 10 gigabit switch. So this is the solution.
Thank you, Borut. On the networking, we can discuss more about it.
Yeah.
And we will have a celebration because it's a birthday for OpenStack. So we have a cake, and afterwards we have some beer and pizza, also on OpenStackFoundation. We have, it's not a request, it's a thing. They want to do it together in OpenStackFoundation. They want to make this birthday celebration in several languages. So they want to hear how it is in Romanian. Happy birthday, OpenStack. So we'll have this kind of small moments. It will be filmed and then posted on the internet. So and afterwards, each one of you, if you want, you can have some few words about the OpenStack. What do you want to wish for OpenStack? Doesn't matter if you are doing this in English or in Romanian. Of course, it's better in English because we will not translate it afterwards. But it's a desire. They want to make a footage with all this celebration in several groups in several countries, and they will present it in the next meeting they will have. I think it's 25th or 27th July. They will have this meeting, and they want to emphasize the scale that OpenStack already taken worldwide. So I'll bring the cake.
Adică nu folosesc sistemul contribuitor. Și ne-am dat driverul de Hyper-V. Am scris un driver pentru Hyper-V. Adică OpenStack am la început de
Așa, și acum zicem, cum zicem, la mulți ani?
OpenStack.
Da, la mulți ani OpenStack, da? Da, să vedem. Da, o să zicem tot, nu așa, da. O să se poată să zicem. Ok. Closer. Closer, closer. Veniți mai aproape. Gata? La mulți ani OpenStack! La mulți ani OpenStack! Super! Și acum să lucrăm.
Mai durează jumătate.
Mai oricum, transmiterea că avem suficient
nu prea complicat.
tot și
just wanted to call it. Yeah.
No,